Hi viewers, welcome to LMR Solution. Today we are going to see about how to detect high impedance fault in the distribution feeder or distribution system. High impedance fault nothing but the conductor won't be touched with the tree or is touched with the ground. That means tree and ground will be create a high impedance path. But due to this high impedance fault, there will be a fire will be generated. So here you can see that different things. So this is because of the high impedance fault. This is the example for a high impedance fault. Here you can see the different scenario. So these are the example for a high impedance fault on concrete surface, high impedance fault on grass surface. You will see the different high impedance fault. We need to detect that fault and you have to figure out what kind of high impedance fault is occurring in the system and then which line is affected by the high impedance fault. Here we are going to do that mean we are going to create the high impedance fault in the distribution system in MATLAB, and then how we are going to detect that high impedance fault by using neural network. Here you will see that this is a Simulink model we developed for the testing that the high impedance fault in the distribution system. For example, it have two end, sending end, receiving end, both end having 33 kilovolt, and then the 33 kilovolt will be stepped down to 11 kilovolt by using step down transformer, and then it have feeder lines, and then here we have 11 to 33. That means we are going to step up the voltage from 11 kilovolt to 33 kilovolt and then send to that receiving end. Here you can see that here we are creating that high impedance fault. You will see that the structure of high impedance fault. This is structure of high impedance fault. Here you will see that this is structure of high impedance fault. So we need to create that structure of high impedance fault. When you would to click this one on this paper, you will get the detail. Here you can see that this is structure of high impedance fault. So we need to create that high impedance fault in the distribution system. Here the same kind of simulation model we are going to implement it here. Here you can see that this is a high impedance fault model in MATLAB. We refer that paper. We refer this paper and then we develop that high impedance fault in the MATLAB, and then it will be create that high impedance fault in the system. This fault can be created in the any of the three line, phase A, phase B, or phase C. Here the high impedance fault is connected with the phase A, but now I'll not create a fault here. So just I'm going to simulate this model. Here you will see that this is a sending end voltage and current. Here you will see that the sending end current for different line, and then here you will see that RMS value of that sending end voltage, and here you will see that RMS current of this sending end side, and then here you will see that receiving end voltage and current. Here we are not creating any fault. Now I'm going to create the fault at a time of 0.1 seconds at the line A. It will be create the high impedance fault at the line A. And now I'm going to simulate this model. Now you check the result. The phase A only having that current of around 30 amps. So here you will see that phase A only affected by the high impedance fault. Here we need to detect that fault. Which line having high impedance fault? For example, I'm going to change this line to here. I'm going to create the fault in the phase B. Now I'm going to simulate the model. Now we can see that it will be create the problem in the line B only. Because of that, it will be that means current will be very high. Because of that only that fire problem is occurring the and because of that high impedance fault on the concrete surface or a grass surface. So we need to detect this problem. For that we are going to collect the data of the sending end voltage and the sending end current as input data, and then output data. Based upon that target we have to create some logic. Here already we collect the data. This is a data. This is input data for the different fault. That means achievement fault in the phase A, phase B, and phase C, and the normal case. So this is a target data. So target data we are fixed at 3 value 0, 0, 0, 0, 1, 0, 0, and then 0, 1, 0, and then 0, 0, 1 to classify the data. And then this data going to be used to for train the neural network. Here I'm going to use end and start, and then click to fitting app and click next, and then here I'm going to load the input data. Here I'm going to load the target data, and then click matrix rows, and then click next, and then here I'm going to train the neural network. After training, I'm going to simulate the Simulink diagram for neural network. This diagram, this neural network used for detect the fault as well as classify the fault. That means which line having the high impedance fault. For that we can use this one. Next, I'm going to open that final model of the system. This is a final model. Here you can see that the input will be voltage and the RMS current of the sending end. The neural network will receive the this 6 input and then it will provide the logic output. That means we will get 3 output. Based upon that, we have to detect that mean. So this scope will be provide the status of fault. Fault is occur or not. This will be provide the status of the fault in the line, which fault having high impedance fault. So now I'm going to change the that means resistance of the surface will be 70 ohms, and then here the high impedance fault will be created in the line C. Now I'm going to simulate this model. Now you can see that the fault is detected, and then classified fault is a high impedance fault at the phase C. Suppose I'm going to change this detail to phase B, and then I'm going to simulate this one. Here also fault is detected. Here the classification of fault is high impedance fault at the phase B. Next I'm going to create the fault in the phase A and then simulate the model. Here you can see that fault is detected and then fault is classified as a high impedance fault in the phase A. And during that time, here you can refer this the current of the sending end and voltage of the sending end. Here you can see that the current and voltage of the receiving end also. So high impedance fault when we affect only particular line. Here by using neural network, we detect the fault of high impedance fault in the system as well as classify the fault which line having high impedance fault by using neural network. Thanks for watching our videos. Kindly subscribe our channel and also click bell icon for notification about upcoming videos. Thank you. Thank you so much. Bye bye.